Well, hello everyone, and welcome to a fresh episode with your girl Audrey Codner, and I am the owner of Math by Audrey. So I want to ask you a question. Can you solve or simplify that in 20 seconds? So if you're here, we're just going to go ahead and start our timer and see if you can solve this step by step in 20 seconds. I usually have these as little shorts, but I decided, you know what? We can combine all of this and put it in one live episode. So we can just go ahead and break things down. So let's see how you did. All right. So when you're breaking down the expressions, we should always go immediately to our phrasing of please, excuse, my dear, and Sally, and the part that everyone tends to forget from left to right. Okay, so a lot of students assume that especially when you get to the multiplying and dividing, it means you do multiplication first, then division next. No, it's multiply or divide, depending on what happens first when you read it from left to right. The same thing goes with addition or subtraction. You do whatever comes first from left to right. So first thing, we want to work on our parentheses. So we have 3 plus 4. So 3 plus 4, that will give us our 7. And then everything else is going to come on down. So I like to take things step by step so you actually see where everything is coming from. So we're done with the parentheses. I noticed that we do not have any exponents anywhere, so we can move on. So now we're looking at multiplying or dividing from left to right. Well, for our numerator, we have that multiplication. So if we got our 18, and we're going to multiply a negative 2 times a positive 7. So negative 2 times positive 7, when the signs are opposite, your answer is going to be negative. Then 2 times 7, that gives us our 14. And all of this is over 2. So we took care of some multiplication. Now we have a little bit of subtracting to do in the numerator to solidify before we can divide. So now we have our 18 minus our 14. So 18 minus 14, that gives us our 4. So we're going to transition over here. And it'll be 4 over 2. So now we can do our division. And you're probably saying, well, Audrey, how come we're able to do that subtraction before we did the division? Because everything, if we think of it this way, we want to take the numerator or the denominator as if it's like one situation. Okay, so if we want to clean up the numerator like we did here, first we started off, we had some multiplication to do. If you wanted to distribute the negative 2, you could have done that. You'll get the same answer, but you're just making it a little bit elongated. So if we go with the parenthesis, then you have your 7. Then we can do our multiplication. Then we have our 18 minus 14. And when we do that, we get our 4. And the only thing in the denominator that we carry down is our 2. So now 4 divided by 2, that gives us 2. So our answer for this will be 2 as we go through and walk through it step by step. All right, so let's take a look at the next one. Because what I do is I like to touch on some of the concepts that a lot of students usually kind of miss out. So we can make those corrections so you can do well for, say, an algebra class, or maybe even your GED or the ASVAT if you're trying to get into the military. Also your Accuplacer if you're thinking about going back to school and they just want to figure out what math class should they put you in. So if you need some immediate, intermediate assistance, or you can go straight into college algebra. So now for number 2, we have an inequality. The way that we solve our inequalities is very similar to what you do when you're solving an equation, but there is a twist. And the twist is usually what gets about 92% of students. So let's treat it almost like an equal sign for right now. So the goal for equations and inequalities is to get your x by itself. So right now, I want to leave this negative 4x on the left-hand side. So what do? I need to isolate it. So that means this positive 7 needs to leave and go to the other side of the inequality. So in order for me to move things from one side to the other side of an equation or inequality in this case, is we have to do what's called the inverse. Now, the inverse of positive is going to be negative. So we're actually going to subtract 7 on both sides. So when we do that, we have a positive 7 minus 7, so that gives me a 0. But we don't need 0 as a placeholder. All we have to do is just bring down our negative 4x. Also bring down our greater than. And then what's 23 minus 7? That is a positive 16. So since we're trying to get x by itself, we have negative 4 times x. If you look in between the number and the variable and you don't see a plus or minus sign in between, that means you are multiplying this one expression. So then what's the inverse of multiplication? Well, it's division. So we're going to divide. Whatever you do to one side of the inequality, you do to the other. So we're going to subtract, or basically divide, a negative 4. So a negative divided by negative will give me a positive. And then 4 divided by 4, that gives me 1. So 1x and x means the same exact thing. Okay, so you don't have to put a 1 in front of this x and then divide everything by 1 at the end. No, you're giving yourself too much work. But then we have 16 divided by negative 4. When the signs are opposite, that means your solution is going to be negative, and 16 divided by 4 gives us 4. So now this is the part that 92% always miss. So when you're doing with inequalities, the key part is right here. Anytime you multiply, or in this case, divide by a negative number, that means this inequality has to change direction in order for us to get some true statements. So if I change it, it's going from greater than to less than. Now, if I didn't change it, plain devil's advocate here, say if I said x is going to be greater than negative 4 and I didn't change the direction of inequality. A number that's greater than negative 4, the easiest one is 0. So if I plugged a 0 back into the original inequality, anything times 0 is going to give me 0. And 0 plus 7, that gives me 7. So this is the situation that's going to be presented if I don't flip the inequality sign. It would say that 7 is greater than 23. So is 7 greater than 23? No. Okay. Would you rather have $7 or $23? Right now, 23, because 23 is going to be greater than 7. That's the reason why you change the direction of the sign. Because now, if I say x is less than negative 4, okay, a number easily less than negative 4, let's say negative 5. So if I plug the negative 5 in for this x, let me write that over here. So I have negative 4 times negative 5 plus 7, and we want to see if it's going to be greater than 23. So what we're doing, we're checking our answers. checking to see if we change the direction of the sign appropriately. So negative times negative will give me a positive, and that's a positive 20, plus the 7, that will give us 27. Now, is 27 greater than 23? Yes, it is. So that's why it's important for us to change the direction of the sign when you're multiplying, or in this case, dividing by a negative number. Okay, that's the key part. So how we solve, like isolating the variable, is going to be similar to what you do in an equation. But when it comes to inequalities, anytime you're dividing or multiplying by a negative number, you must change the direction of the inequality sign. Okay. Now, here's another plug that I want to put in. So let's say we had a different problem. Say the problem was -3, and -3x is greater than or equal to, I'm just putting numbers out there, greater than or equal to 9. Okay. Then another situation would be 4x is less than -12. Okay. So two different situations, but I want to make a point. So when you are dividing, over here, we're going to divide by -3. So a negative divided by a negative will give me a positive. Basically, the threes are not canceling out necessarily. It's going to equal a 1, but 1x and x is exactly the same thing. Now we have 9 divided by -3. That gives me a -3. And am I changing the direction of the sign? And how can you tell? Well, we have greater than or equal to, and what did we divide by? We divided by a -3. So yes, we have to change the direction of the sign. We're not getting rid of the equal to, we're just changing it from greater than to less than or equal to. But this is the part that kind of gets a lot of people a little screwy. So with the 4x is less than -12, we know we can divide both sides by 4. Okay, that's nothing unusual. Then they'll say x, and they'll say, oh, -12 divided by 4, that gives me a -3. Oh, that means I have to change the direction of the sign. No, 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 no. Okay? You only change the direction of the sign is what you're dividing is a negative number, not the result, what you are dividing. That's the key part. And a lot of people get things wrong because they think that they got a negative result. That means you change the direction of the sign. No, it's all based on, did you divide or multiply by a negative number? In this case, we did not, so the inequality stays exactly the same. Okay? It's all based off of what you multiplied or divide to see if you change the direction of the sign. All right? So let's get a couple more in us. I know it seems like, we're jumping from one thing to the next, but this is basically what happens in a lot of their exams, okay? It's never just one thing and one thing and one thing. It's always like, let's jump from one thing to the next, to the next, to the next. So if I can develop one thing that I know a lot of us are very scared of, it's going to be fractions. Let me see if I can get my holder of my stuff together. Okay, so I get some room down here. So now, I want to know if you have 2/3 plus 5/6 minus 1/4. So we're not setting it equal to anything. We want to simplify this. So we want to do the proper operations, but we want to simplify this. Now, since we are adding or subtracting, the key part is I need to know what would be my least common denominator. Okay? So we need to take a look at the multiplication facts for each the 3 times table, the 6 times table, and the 4 times table to see what do they have in common. So if we list it out, you have the 3 times table, which you have your 3, 6, 9, 12, 15. Okay, I'm going to stop here. There's more. For the, I'll do it numerically, 4 times table, we have 4, 8, 12, 16, 20. Okay, and that continues on. And then the 6 times table, we have the 6, we have 12, we have 18, we have 24. Okay, and that continues on. So what we want to know, what is the least, the lowest number that they have in common? And it has to be something that all 3 numbers have in common. And it's kind of interesting that they're all here on a diagonal. Okay, yes, the 3 and the 6 both have a 6 in common, but the 4 doesn't have that. So that's why we can't say 6. All right. So now, and then plus if I kept going, I would have 18 in the 3s and then 18 in the 6s. But again, there isn't an 18 in the 4s. So we need for our denominators to all turn into 12s. So this is going to be a 12. This will be a 12. And this will be a 12. So we need to think, how am I going to change this 3 into a 12? Well, through multiplication, you can multiply by 4. Whatever you do in the denominator, you're going to do the same exact thing in its numerator. How do I change the 6 to a 12? I can multiply it by 2. Whatever I do in the denominator, I also do in its numerator. And if I want to change this 4 to a 12, I need to multiply by 3. Whatever I do in the denominator, I also do in its numerator. Okay? As you say this and you practice these things, fractions is not going to be so much of a problem. I'm not saying you're going to marry it. Yeah, you might date it, but you don't have to do anything further. Okay? So now, 4 and 3, we already got our 12. So now 4 times 2, that gives us our 8. Then 6 and 2, we already know it's 12. 5 and 2, that gives us our 10. And 4 and 3, we know it's 12. And 1 and 3, that gives us our 3. So now we have a common denominator. All we need to do is combine the numerators. So my denominator is going to be 12. So I need to add the 8 and the 10. That gives me 18. And take that 18 and minus 3. So the 18 came from the 8 plus 10. Then we're going to subtract 3. Notice I went from left to right. So that will give us our, let's say, 15. Okay. Now 15 twelfths. We can simplify. This is an odd number. This is an even number. So the first number that I will think is saying, could this be divisible by 3? So if I divide the numerator by 3 and I divide the denominator by 3, I'm going to get 5 fourths. So I could leave my answer as this improper fraction of 5 fourths. Or I can actually divide 5 divided by 4 and I can get a mixed number, which will be 1 and 1/4. Or I can actually divide it and get 1 and 25 hundredths. Either way, it depends on what is being offered as an answer. Okay, so when I say this, I'm basically doing a lot of this for your standardized tests. Now, classrooms, some teachers don't mind having it imperfect. Some teachers want it as a mixed number, and some teachers don't mind having it as a decimal. It's going to be up to the teacher and up to the directions. So how far we get to go. All right. Okay. So far, if you like these and you're like, you know what, I need more practice with these, you can also check out the link in my profile on my Stand store, which has a lot of practice books. It has a lot of instructional books where you can actually see me doing just what I'm doing here. I can have videos that's going to be inside. I have a 10-book series called Algebra at Your Pace, where you're basically learning the concepts of algebra step by step. Mostly the things that you're going to see in the GED, the ASVAT, and the Accuplacer test. So it can really kind of hone in on your skills. So when you see this in the test, you're no longer going to freak out. You're going to like relax. You're going to be able to say, yes, I remember practicing this, and then you're going to go ahead and apply. All right. So if you're interested in any of these books, or even my ultimate math notebook that I'm using to do the sessions, okay? This is what I have on my pages. So if you're ever doing like single step things, you can put your formulas, you can write your steps. And the one other thing that I like on the back is I do a lot of the stuff that you generally forget. Okay, so like my factor sheet, also like complex numbers for this one, but I also have a lot of basic stuff with like the skills of algebra. All right, so let's do 2 more, and then we are done for today. Okay, I don't like to give too much, but just enough to kind of wet your whistle a little bit. So if we're looking at system of equations. Now, if you're planning on taking the GED, each question has a certain value. All of them are not graded on the same scale. So you'll have like 1-point questions, 2-point questions, 3-point questions, 4-point questions. And this system of equations is definitely a 4-point question. I almost forgot what example I'm on. Okay, so we have 3x plus 2y is equal to 12. And we're just doing some of the naked math right now. 3x minus 2y is equal to 0. And we want you to find the values of x and y. So we want to know what are the values of x and y that's going to give us some true statements. Now, one of the things that a lot of people generally like to do is to do either elimination, they can do a combination like substitution, or they can graph. Now, if you're taking a standardized test, I'm going to be truthful. Graphing is going to take way too long. And just by looking at what we have here, your best option is to do what's called elimination or linear combination. The reason why is when you eliminate, you want to have one number with the same variable. One's going to be positive and one's going to be negative. I notice right here with my y's. I have the same y's and I'm looking at it vertically. I have a positive 2 and I have a negative 2. I know if I add these two together, I can eliminate the y's and then focus my attention on the x values. But in order for me to do that, I need to add these two equations together, just like we used to do back in the day. So if I add a positive 2y and I add to a negative 2y, that will give me 0y or just 0. But 0 is a placeholder. And we don't need a placeholder on this side of equal sign because we got these two x's that we can combine. We have 3x plus 3x. So 3x plus 3x, that gives me 6x. Okay? And then on the other side, we're going to add the 12 and the 0. Well, that gives me 12. So now we have 6x is equal to 12. We can solve for x. Now we just got one variable to deal with. So 6x means 6 times x. The inverse of times is division. So we're going to divide both sides by 6. So that gives us x is equal to 12 divided by 6, which gives us 2. So we found half of our answer. We found what x equals. But now we need to find what y is. So a lot of you guys were like, do I have to rewrite everything? No. You get to pick one of the two original equations, okay? Because there's going to be times you might have to modify it. Go back to the original equation. It doesn't matter which one you pick, but what you're going to do is where you see an x, you're going to substitute with a 2. So it's going to look like this. So you have your 3 in parentheses plus 2y is equal to 12. So where there is an x, we're going to put a 2. So now 3 times 2, that gives me 6. And I bring down my plus 2y equals 12. So now I want to get y by itself. So right now it's attached to the 2. So that means we need to get rid of this 6. And this is a positive 6 because I'm looking at the signage to the left of the number, not this plus sign. This plus sign is saying that this 2 is positive. So I'm actually going to subtract 6 from both sides. So 6 minus 6 gives me a 0. I don't need that placeholder, so we're going to be okay just for me to bring down our 2y. And then 12 minus 6 gives me 6. And then we're going to divide both sides by 2. So 2 divided by 2 will give me 1y, or just y. And then 6 divided by 2 gives me 3. So you found the values of x and y. The x is going to be 2. The y is going to be 3. So you might be saying, hey, Audrey, well, what happens if I use the bottom equation? Will I still get a 3 for y? Well, then let's check it out. Why not? What else are we doing? So we have our 3. We're going to put our x in. Minus 2y is equal to 0. So remember what our x was? Our x is 2. So I'm substituting the 2 in for the x. So we still have 3 times 2, which gives me 6, minus the 2y is equal to 0. I'm going to subtract the 6. Okay, so far, most things are sounding pretty normal. But what comes down is my negative 2y. And then 0 minus 6 gives me a negative 6. Okay. So we want to get y by itself. So what do? We're going to divide both sides by that negative 2. So negative 2 divided by negative 2 gives me a 1y, or just y. And then a negative divided by a negative is a positive, and 6 divided by 2 is 3. Okay? So hopefully this shows you that no matter which of those two original equations you pick, you're going to get the same result. Okay? Because we're plugging in for that too. All right? And one more. This is another one that is a 4-point question, and we do not, I repeat, do not want to skip it. So let me show you step by step, and then we're done for today. All right, so right now I want you to factor, and I want you to factor x squared plus 7x plus 12. Okay, I want you to factor this. So what does factoring mean? Factoring is basically doing the distributive property in reverse. So I know I'm going to have two factors for this expression. The reason why, my highest degree is to the second power. So I can go ahead and split into two parentheses. And since we have x squared, that means x times x. So I can go right into splitting my x's. So this is the part that I feel is the absolute hardest. Now, if you're not strong with your multiplication facts, this is going to be a little challenging. But you will, as you go through it, you will be able to understand it. What we're going to do is called the AC method. The reason why it's called the AC method is because our original expression is plugged in as standard form. And standard form is ax squared plus bx plus c. So the coefficient or the number that's in front of your x squared is going to be your a. The coefficient or the number that's in front of your x, that's going to be b plus its signage. And the constant, the one that's not next to an x or y or any letter, that's going to be on the end. That's your c. So our a is 1, our c is 12. The reason why they call it the AC method is because you're going to multiply your a and your c. So 1 times 12, that gives me 12. And you're going to rewrite your b. Our b is a positive 7. Okay, not too bad so far. But this is the part that gets a lot of students. We need to think what two numbers multiplied will give me a 12 and added, the same two numbers add together will give me a 7. Okay, think about it. So what two numbers multiplied together will give me a 12 and add together to give me a positive 7? So let's think about it. So we have, for 12 times tables, you got 1 times 12. You have 2 times 6. You have 3 times 4. All three of these multiplied will give me a 12. But if I added any of those, which one will give me an answer of 7? Well, if I did 1 plus 12, that'll give me a 13. That's not going to work. We have our 2 plus 6. That gives me an 8. Close, but not what we're looking for. Then we have 3 plus 4. That gives me my 7. Those are the factors that we want. So I can put a 3 here, and I can put a 4 here. Now, you can put the 4 here and the 3 there. That's the one best thing about multiplication. It's commutative. Okay, so if I said 3 times 4, that gives me 12. 4 times 3, that also gives me 12. So since both of them are positive, I'm going to write a plus 3 in one parenthesis and then a plus 4 in the other. So what you did was you found your factors for this expression. Okay? And if you ever want to check it, all you have to do, what I say, Factoring is the opposite or the inverse of distributive property, right? So why not distribute? So if I do x times x, see if I can use this pen. So if I do x times x and x times 4, if I want to check it, I will get my x squared plus 4x. Then I multiply the 3 to the x as well as the 3 to the 4. So it'll be plus 3x plus 12. Notice right smack in the middle right here, we have like terms. So with those like terms, we can add them up, and that gives me a positive 7x. So now I can bring down my plus 12, and I can bring down my x squared. And this is for the check. And notice this expression is exactly the same as our original. All right? So that's what I basically do. I touch up on a lot of the concepts that you do. Sometimes if I'm not here on YouTube, sometimes I'm on TikTok, especially at 7:45 or nowadays 8 o'clock in the morning, Eastern Standard Time, and I go through a lot of concepts. But again, if you want something that's going to be a little more structured, instead of like, okay, here's one problem, here's another problem, here's another problem, you can actually get my Algebra at Your Pace books. Okay, so the Algebra at Your Pace books, if you open it up, they'll give you a QR code. When you scan the QR code, it will give you a playlist of all the videos that's associated with it. And you have me walking you through step by step what each of these sections are. So this is volume 4, so it deals with anything linear. So we're looking at graphing linear equations. Notice it gives you a whole bunch of extra practice problems. Okay, also gives you answer keys. Then it gives you a little bit about slope. So we're looking at slope, we're looking at the equation line, parallel and perpendicular lines. Okay, everything, all these concepts, I break it down, and plus I give you extra practice problems so you can solidify your understanding. And towards the end, you're also giving a quiz. Okay, so you're just giving like a small quiz just to solidify what was your concepts of this particular book, just to make sure that you understand it and to practice putting yourself in a tested area. So as you're sitting down, you're walking you through some of the assessment. There is an answer key, okay? And then once you get through the answer key, and sometimes in the very back, which for me, we have a tendency to forget certain concepts. So what do? I put those concepts in the very back. So the rules of integers, order of operation, properties of exponents. We're looking at the linear and the quadratic equations. Okay, all of those concepts just to kind of refresh your memory of how to do certain things if you ever get stuck. So if you want to get access to that and also get access to a free math check, go ahead and click the link that is in my profile. And we're going to see if we can do this once again, at least like once a week. So we go over certain concepts. If there's a concept, and I just basically do like algebra. So if there's a certain concept that you're like, I'm wondering if you can do more about this, go ahead and shoot me a message and let's see what I can do. All right. Well, one, thank you so much for your time and your attention. If you do ever have any questions, just go ahead and shoot me a message and we will take it from there. All right, everyone, have an amazing day, and I'll see you next week.